right, folks, in this video, I'm going to go over the Exam 3 review for Precalculus, for your Exam 3 in Precalculus. And so hopefully you have the Exam 3 review. I've already completed mine, as you can see. And so in the very beginning, days 17 and 18, there's 15 graphs that you have to be able to identify. And what I'm going to do is I'm going to go ahead and project them up here on the screen. And we're going to walk through how to identify these graphs. Okay, so here we go. Here's the first one. This is question number 1. And the first thing we need to identify is whether the graph is sine. Well, one of the first things we need to identify is whether the graph is sine or cosine. And the best way to do that is to go to the y-axis and identify where the graph actually intersects the y-axis, which is right here. Now, cosine intersects the y-axis at either the top of the curve or at the bottom of the curve, maybe like this. But this, you'll notice that the y-axis, this graph is intersecting the y-axis in the middle of the curve, okay? And note that this is a wavy curve. Wavy curves are automatically sine or cosine. So this is either sine or cosine, and because this wave intersects the y-axis at the middle of the curve, this is going to be a sine wave, okay? So we know that this is going to be f of x is equal to, we know that it's going to have sine in it. Now we want to try and identify the amplitude, the number that goes in front of sine. And the amplitude is going to be half of the distance between the highest point of the curve and the lowest point of the curve. So if we start at the highest and go to the lowest, or the other way around, and just count from the highest, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So between the highest point and the lowest point is 8. And we divide that by 2, that's going to be 4. So this is going to be, the amplitude is 4. So this is 4 sine. Now we need to figure out what's going to go on the inside. We know that there's going to be an x in there. And now we need to determine the frequency. And the frequency, to determine the frequency, you start at 0 and you go all the way up to 2 pi, which is right here. And you count how many times or how many waves, how many complete waves exist between 0 and 2 pi. So starting here, we're going to go up, down, up. That is one complete sine wave. One complete sine wave is one up and one down and then back to the middle. So up, up, that's 1. Up, up, that's 2. So there are 2 complete sine waves between 0 and 2 pi. So the frequency here is going to be 2. So that's 2x, and then whatever goes on the end, that's going to be where the midline is. So we want to go to the middle of the wave. We said the amplitude was 4, right? We can go to the top and count down 4. 1, 2, 3, 4, and that is where the midline is. And then from here, we count 4 again, 1, 2, 3, 4, and then we're at the bottom. So here's the midline of the sine curve, and you can see that it's at -2, and therefore we're going to put a -2 on the end. Therefore, the first graph on the review is 4 sine of 2x minus 2. Okay? All right, let's go to the second one here. Well, this one is not a wave. And since it's not a wave, it is not sine or cosine. This must be either tangent or cotangent or secant or cosecant. Now, I can tell you right away that this one is secant. I can tell you right away that this one is secant of x, and I'll show you how I know that. Because secant, first of all, sine or tangent and cotangent, they don't have this vacant middle space. All these u's and upside down u's, that's automatically secant or cosecant. Okay, so I already know that. How do I know this one's secant and not cosecant? Well, secant is 1 over cosine, and I know that. See this column right here, that's a vertical asymptote right there. The vertical line that goes between the u and the upside down u there, and that's happening at pi over 2. That's only going to happen when the denominator is equal to 0. And so I know that cosine of pi over 2 is 0. If this was cosecant, that would be 1 over sine of x. And I know that sine of pi over 2, that's 1. And so we wouldn't have a vertical asymptote if the denominator was 1. If the denominator was 1, we'd have 1 over 1, and that would equal 1, and it would pass through this point right here. okay? And so I know that because cosine equals 0 at pi over 2, that there's going to be a vertical asymptote at pi over 2, which there is here, making this one secant, okay? And we'll explain that again when we get to cosecant, okay? All right, let's move on to graph number 3. All right, this is the third graph. And if we go to the y-axis, you can see that the graph intersects the y-axis at the bottom, not at the middle. At the bottom, that means it's cosine, okay? So we're going to go f of x is equal to cosine. Now here's the other thing. I didn't mention this on question number 1. We didn't look to see whether it was negative or not. The first one was not negative because up, down, up, that's positive sign. It would have only been negative if it had gone down, up, down. That would be negative sign. Well, this one, cosine is positive if the y-axis goes through the top of the curve. But this is, look, this is the bottom of the curve going to the top. Because the y-axis goes through the bottom of the curve, that means that this cosine curve is upside down. That means that this cosine is negative. Let me make that a little clearer. F of x equals, and we'll have a negative on there. Now we want to know what the amplitude is. So we'll go to the top and the bottom and count the distance from the top. 1, 2, 3, 4. Half of 4 is 2, so the amplitude of this curve is 2. So we know this is going to be negative 2 cosine. We've got to find out what's going to go inside with the x. What's the frequency? And so we're going to go from 0 up to 2 pi and see how many full, complete waves there are. We start down here. We go up and then down, and then it stops. That's one complete cosine wave between 0 and 2 pi. So there's a 1 here, so it's 1x or just x. So this is going to be negative 2 cosine of x. And now we want to know, what is the vertical shift going to be? What's the midline? Well, if we go to the top and the bottom and go halfway, that's right here. This is the midline, and that is negative 4. And so this is going to be negative 2 cosine of x minus 4. All right, let's move on to graph number 4. All right, so go to the y-axis. We can see once again that it's hitting the bottom of the curve. That makes this a negative cosine. Negative cosine. The amplitude between the top and the bottom is 1, 2. Divided by 2 is 1. So that means that this is just negative 1 cosine or just negative cosine. Okay, because the amplitude is 1. The frequency going from 0 to 2 pi is from here down, up, and then down. That's one curve. That means it's 1x or just x. And lastly, let's identify the vertical shift. Here's the high point of the curve. Here's the low point. Halfway between is right here. And that's the midline, positive 2. So we'll put a plus 2. So this is the curve of negative cosine of x plus 2. We're going to throw an f of x on the front there. So f of x is equal to negative cosine of x plus 2. All right, let's move on to curve number 5. I believe this is 5. Confirm here. Let's see. Yep, this is number 5. All right, so go to the y-axis. Here's the y-axis. It's going through the middle of the curve. Okay, see, that's the middle. And the curve is going down, up, down. So this is a sine curve, but it's negative because it's going down, up, down instead of up, down, up. So this is negative sine. Let's find the amplitude. Here's the highest point. Here's the lowest point. Count from here. 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3, and therefore this is, the amplitude is 3. So this is going to be negative 3 sine of, let's see what goes on the inside. We're going to identify our frequency. So we're going to go from 0 up to 2 pi and see how many sine curves there are. That's 1 sine curve, 2 sine curves. So that's 2 sine curves between 0 and 2 pi. So that's a frequency of 2. So that's 2x. And then we need our vertical shift. Let's see, we go to the middle. Here's the middle right here, which is at positive 1. So that's a plus 1 vertical shift. And therefore, this is negative 3 sine of 2x plus 1. All right, let's try question number 6. Here's 6. Go to the y-axis, it looks like it's hitting in the middle of the curve, and from the middle it's going up, down, up. That means that this is a positive sine curve. So sine f of x equals, let's find the amplitude, highest point to lowest point, 1, 2, divided by 2 is 1, so the amplitude is 1. That's 1 sine of, let's find our frequency, from 0 to 2 pi. So from here to here, that's 1 curve, 2 curves, 3 full sine curves up to 2 pi, so that's 3x. And then the vertical shift, the middle of it is at 4. See that? Middle is at 4, that's plus 4. So this is the graph of f of x equals sine of 3x plus 4. Okay. All right, let's try question number 7. All right, 7 here, this is not a wavy line, so this must be either tangent, cotangent, secant, or cosecant. It's not secant or cosecant because secant and cosecant don't have any output values in between 1 and -1. So that means this must be either tangent or cotangent. And we know that tangent is sine of x over cosine of x. So we're looking for where this is equal to 0. Wherever cosine of x is equal to 0, there's going to be a vertical asymptote because the denominator is not allowed to equal 0. Well, we know that cosine of x equals 0 at pi over 2 because cosine of pi over 2 is 0. So if we go to pi over 2, that's right here. If there's a vertical asymptote, then this must be tangent, and it is. So this is tangent. The other reason we know it's tangent is because we have a positive slope, positive slope, positive slope. Cotangent has a negative slope in all of its curves. Okay, so this is the graph of, this is going to be f of x equals tangent of x. Okay, all right. Now let's try question number 8. All right, we got a wave here, so it's either sine or cosine. We're going to go to the y-axis, which is right here. The y-axis intersects the curve at the top, so that means it's a cosine curve, and because it's the top and not the bottom, that means that it's a positive cosine curve. So we know that this is going to be f of x equals, there's going to be a cosine in there, and it's positive, not negative. The top to bottom, the highest point to the lowest point, if we count, 1, 2, 3, 4, divided by 2 is 2, so the amplitude is 2. So this is 2 cosine. Now let's find the frequency. Going from 0 to 2 pi, we're going to go 1 curve, 2 curves, 3 curves. That's 3 cosine curves from 0 to 2 pi. So that means the frequency is 3 with an x. And now we just need our vertical shift. Our vertical shift is going to be halfway between the high and low point. So let's go halfway right here. That's at positive 4. So this is a plus 4. So this is the graph of 2 cosine of 3x plus 4. Okay. All right, let's try question number 9. Let's see here. There we go. There's question number 9. So we got a wave, so it's sine or cosine. Go to the y-axis. It hits in the middle, so this is sine, and it's going up, then down, then up. So this is positive sine. And so since this, so we know that this is going to be f of x is equal to positive sine. Now we need to find out what the amplitude is. High point, low point. Count 1, 2, 3, 4, 5, 6. So it's 6 from the top to the bottom. Divide by 2, that's 3. The amplitude is 3. So this is 3 sine. Now, how many sine curves go from 0 to 2 pi? Up, down, up. That's 1 sine curve. So the frequency is 1, so we'll just put an x. And now what's our vertical shift? Well, halfway between here, the high point and the low point is right here. That's positive 2. And therefore we have a plus 2 shift. I also want you to notice that that if it's a sine curve, it actually hits the y-axis at the midpoint, and so that can be helpful too. All right, that's number 9. Now let's do curve number 10. All right, this is not sine or cosine. This is not tangent or cotangent because it's vacant in the middle. It's got the U shapes, so this is either secant or cosecant. The other one we did was secant. That probably means this one's cosecant, but let's make sure it's cosecant. Cosecant is the same as 1 over sine of x. And it looks like there's a vertical asymptote right here at 0. Is sine of 0, 0? Yes, sine of 0 is 0, so at x equals 0, the denominator will equal 0, and that will be a vertical asymptote, and therefore this is f of x equals cosecant of x. Okay, that's number 10. Now let's try question number 11. All right, here's 11. It's a sine wave, so it must be either sine or cosine. And so, or it's a wave, so it's either sine or cosine. So go to the y-axis. It hits the graph right here. That looks like it's in the middle. And because it's in the middle, it's got to be sine, but it goes down, up, down. Therefore, it's negative sine. So this is going to be f of x equals negative something sine. Let's find out what the amplitude is. High point, low point. Count the difference. 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. Therefore, the amplitude is 4. So this is negative 4 sine of, let's find out what the frequency is. Going from 0 and up to 2 pi, we're going to go down, up, down. That's one full curve. So that means the frequency is 1. So we'll just put an x. And now we just need to identify the vertical shift. So between the top and the bottom, we're going to go 1, 2, 3, 4. Here's the middle right here, which is at negative 1. So we'll put a minus 1 on the end. And so question number 11 is negative 4 sine of x minus 1. Okay? All right. Let's now look at question number 12. Whoops, I just went backwards. That's 10. That's 11. This is 12. Okay. All right. So question 12. Go to it's either sine or cosine. Let's go to the y-axis. It's at the top. That means it's cosine, not sine. And because it's at the top and not the bottom, it's positive cosine. So we know that this is going to be f of x is equal to positive cosine. The amplitude is the distance, half the distance from the top to the bottom. So 1, 2, 3, 4, 5, 6 from top to bottom. 6 divided by 2 is 3. So the amplitude is 3. Cosine of, let's find the frequency from 0 up to 2 pi, down, up. And therefore, that's one full cosine curve. So the frequency is 1. So that's 1x or just x. And now we need the midline. The midline is halfway between the high and the low point. So let's go halfway. Here's the halfway right here, which is positive 1. So this is a plus 1 shift. So the graph of this function is, or the function for this graph is 3 cosine of x plus 1. All right, let's move on to question number 13. Here's 13. 13, wow, this is really weird looking. All right, let's go to the y-axis and go down here, and it hits the graph right here. That looks like a low point, the bottom of the curve. That means it's cosine, not sine, because sine would be in the middle. And it's the bottom of the curve, not the top of the curve, so it's negative cosine. So this is going to be f of x is equal to negative some kind of amplitude with cosine. Let's find the amplitude. Okay, it's going to be hard. Here's already a low point, and here's a high point. It's going to be hard to count. The high point is at 3. The low point is at negative 5. So let's count from here. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 2 is 4. So that's negative 4 cosine. And now let's find the frequency that goes inside the parentheses with the x to 2 pi. All right, look, here's one full curve. Up, down. Well, we don't even make one full curve. If we start here and we go to 2 pi, we stop. We're only halfway. That's half of a curve. So that means that the frequency is 1/2. So we can either write, we can do 1/2 x, 0.5x, or 1/2 x is the same thing as x over 2. So I'm going to go ahead and write x over 2. But if you want to write 0.5x, that's fine too, as long as your frequency is 1/2. The last thing we need now is the vertical shift. And so let's go to the top and the bottom. Here's the bottom, here's the top. Go halfway between. There, 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 there. It looks like the halfway is negative 1. So we'll put a minus 1. And this is the graph of negative 4 cosine of x over 2 minus 1. Okay? All right, good. Now let's do question 14. All right, we got a curve down here. Looks like a sine wave or a cosine wave. Y-axis hits the curve in the middle. That makes it a sine wave. Okay, and it's going up, down, up. That makes it a positive sine wave. So we have f of x is equal to positive sine of something x. Let's find the amplitude. here's a high point, here's a low point. Difference is 1, 2, 3, 4. So vertical distance of 4 divided by 2 is 2. So this is 2 sine of, let's find the frequency. And the frequency starts at 0 and goes up to 2 pi. And so we go up, down, up. That looks like one full sine curve, and therefore it's 1x, or just x. And then the last thing we need is the vertical shift. So from here to here, the middle is going to be right here, which is -4. So we'll put a -4 on there. And so this is the graph of 2 sine of x minus 4. All right, last one, number 15. All right, this is not sine or cosine because it's not a wave. This is either tangent or cotangent. And look, it's got to be cotangent because it's got a downward slope, right? Downward slope. On top of it having a downward slope, also look where the vertical asymptote is. The vertical asymptote is at 0. And so cotangent of x is equal to cosine of x over sine of x. And sine of 0 is 0, and therefore this would be cosine over 0, which would be a vertical asymptote. So this must be f of x equals cotangent of x. And that is the graphs, questions 1 through 15. Okay? All right, so let's do this now. Let's now look at question number 16. We're now moving on to day 19. Day 19 says evaluate a bunch of inverse trig functions. And the first one says, this is question 16. So 16 says, what is sine inverse of square root of 3 over 2? And so here's what we have to remember. Cosine inverse and sine inverse, instead of, if we had what is sine, we would have sine of, pi over 2. And we know the answer to sine of pi over 2 is 1. So when you're asking sine, it's sine of an angle measure is equal to a coordinate. Well, now when we do sine inverse, it's sine inverse of a coordinate is equal to an angle measure. And so now instead of being given a pi and having your answer the coordinate, now you're putting in a coordinate and your answer is a pi. Now here's the thing though. On the unit circle, let me go ahead and draw a unit circle real quick. All right, so now we have a unit circle that we can work from. Here's the problem is that if I ask what angle measure, this is asking what angle measure will the answer to sine be square root of 3 over 2? Well, sine is the y-coordinate, so here's square root of 3 over 2, but here's also square root of 3 over 2. So the answer can be either pi over 3 or it can be 2 pi over 3. And here's what I need to remind you, is that the answers for sine inverse are only from here down to here. But the problem is we start at 0 and we go forward by one quadrant, and then we go backwards by one quadrant. Though technically these points are 11 pi over 6, 7 pi over 4, and 5 pi over 3. For the purposes of sine inverse, those coordinates are actually negative pi over 6, negative pi over 4, and negative pi over 3. And then this one is not 3 pi over 2, it is negative pi over 2. And so if this was one of our the numbers on the inside, we would actually choose one of these purple numbers, not one of the original numbers from the unit circle. On the other hand, if we're being asked about cosine, cosine is going to run from 0 up to pi, and so our answers can be anywhere from 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, or pi. Okay? So in this case, we're being asked sine inverse of square root of 3 over 2. There's square root of 3 over 2. We're only going to pick an angle that's between here and here because the domain of, the range of sine inverse is going to be, the answers can only be between negative pi over 2 and pi over 2. And therefore, we have to pick something that falls between negative pi over 2 and pi over 2. The only one of these that has a coordinate of square root of 3 over 2 that's between negative pi over 2 and pi over 2 is, see, these are all negatives. That's 0, that's 1/2, that's square root of 2 over 2, square root of 3 over 2. That's our answer. Our answer is going to be pi over 3. So the answer to question number 16 is pi over 3. All right, so now let's look at 17. I think we can probably go a little bit faster now that we've got the unit circle and we understand what we're looking at. This says cosine inverse of square root of 2 over 2. And so all of our answers for cosine inverse have to start here and have to end over here. Well, only one of these points has square root of 2 over 2 as the x-coordinate, and that's this one right here. So the answer is pi over 4. Pi over 4. And now let's try 18. 18 says sine inverse of negative 1/2. Sine inverse of negative 1/2. All right, so we're going from here up to here. Negative 1/2 for the y-coordinate is right here, so that is negative pi over 6. So the answer to this is negative pi over 6. Question number 19 is cosine inverse of negative square root of 3 over 2. And so we want to find cosine inverse. All the answers are from here to here. We want negative square root of 3 over 2, which is right there, negative square root of 3 over 2 for the x-coordinate. So our answer is 5 pi over 6. 5 pi over 6. So now let's do question number 21. Question 21 says cosine inverse of 0. Cosine inverse of 0. So between here and over here, the x-coordinate is 0 right here. So that's pi over 2. So that's, where are we at here? 21, pi over 2. All right. Oh, we skipped 20. Oh, I'm sorry, I skipped 20. Well, that's 21. Let's do 20 right here. Question 20 is sine inverse of negative 1. All right. So that's the sine is the y-coordinate. The y-coordinate between here and down here is right here, negative 1. And so the answer is negative pi over 2. Negative pi over 2. 20 and 21. Now let's do 22. 22 says sine inverse of negative square root of 2 over 2. Okay? And so now we're looking for where the y-coordinate is negative square root of 2 over 2, and it has to be between here and here. So y-coordinate, negative square root of 2 over 2 right here. That's this point. We don't use 7 pi over 4. We use negative pi over 4. So it's negative pi over 4. And then question number 23 is cosine inverse of 1/2. So we're looking for where the x-coordinate is 1/2, and it has to be between here and here. X-coordinate is 1/2 right here, which is at pi over 3. So the answer is pi over 3. And so that's how we use the unit circle to give answers for inverse sine and inverse cosine given specific coordinates, okay? Then question 24 says that you must know the graphs of y equals sine inverse of x and the graph of y equals cosine inverse of x. All right, so what I'm going to do here is I'm going to turn the projector back on. I'm going to pull this down, and I'm going to show you the graphs of sine and cosine inverse. Let's see here, AV mute, okay. There we go. This is the graph of cosine, this is sine inverse. And we know that it's sine inverse because its outputs range between negative pi over 2 and pi over 2. And we know that sine, the coordinates, which are inputs in sine inverse, they run between negative 1 and 1. And so we know our inputs run between negative 1 and 1 on sine inverse because our outputs are between negative 1 and 1 on regular sine. And we know that all of the answers to sine inverse have to fall between negative pi over 2 and pi over 2. And also the other thing is that we have to recall that sine inverse of negative 1 is negative pi over 2. And sine inverse of 1 is pi over 2. And that's why this curve is the shape of sine inverse of x. And now let's do this one. This one is cosine inverse of x. We know that all of the answers fall between 0 and pi, and also cosine, the inputs on cosine inverse have to go between negative 1 and 1, and therefore the curve has to fall between negative 1 and 1, and it has to fall between 0 and pi. And why is it this particular one? Why didn't it go this way? Well, because cosine inverse of negative 1 is pi, cosine inverse of 0 is is pi over 2, and cosine inverse of 1 is 0. Okay, and so this is the graph of cosine inverse. All right, so now let's move on to question number 25. Question 25 says, we have some algebraic. Okay, so for 25 through 30, you are going to need a calculator. You need a scientific or a graphing calculator. Now, because you need a calculator for this portion, so just so you know, everything that we just did, everything that we have done up till now, on the exam, you will not have access to a calculator during that time. Those questions will be on one portion of the test where you will not be able to have a calculator out. But then when you get to questions like 25 through 30, you will be allowed to have a calculator, which will be the second part of the test. And on that part of the test, you can have a graphing calculator or a scientific calculator. It doesn't matter to me. All right, so question 25. Let me see if I'm going to need this unit circle on any more of this review. I don't need it there. I don't really need it there. I don't think I do. I don't need it there, and I don't need it there. Yeah, let's go ahead and erase the unit circle. So I don't think we need it. I think we only needed the unit circle for that portion of the exam, for the inverses. Okay. All right, so question number 25 says, we got sine of x plus 1 plus 3 is equal to 2.7. All right, I'm going to grab a scientific calculator over here. Now, make sure that it says on here, it says be sure your calculator is set to radians. So if you have a scientific calculator, maybe that looks like this, and you can ask me while you're taking the test, hey, Mr. Ryan, can you help me set my calculator to radian mode? And I will. If your calculator has been cleared, you have to go to this DRG button right here. You have to hit it, and then you have to move over to rad and hit enter, and now you're in radian mode. Okay? If you have one of these calculators, okay, you have to go to mode, and you have to go down at the very top. You got to move over to rad and hit enter, and then hit second quit, and then you're in radian mode. Okay, so you got to make sure your calculator's in radian mode. And now what we're going to do is just going to do some algebra. We're going to subtract 3 here, cancel. Now we have sine of x plus 1 is equal to 2.7 minus 3 is negative 0.3, or just negative 0.3. Now that the only thing we have on this side is sine, we can now cancel the sine with sine inverse. So we're going to do sine inverse to the left and sine inverse to the right. Cancel the sine, carry down the x plus 1 is equal to sine inverse of negative 0.3. Now I'm going to subtract 1 from both sides, and I get x is equal to sine inverse of negative 0.3 minus 1, which I can now key in a calculator. Sine inverse is over the sine button. So I have to hit second and then sine, and I get sine inverse. Then I'm going to key in negative 0.3, then close the parenthesis, then I'm going to put minus 1, And my answer is x equals negative 1.304. Negative 1.304. If you round it to the nearest, it would be negative 1.305. That's fine too, but we're now moving from pre-calculus over to calculus. And when I teach you in calculus, I'm going to teach you how to truncate instead of rounding. So we're truncating to the to the third decimal here, and we're going to put negative 1.304. Okay. All right, let's do question number 26 then. 26 says 5 cosine of 3x is equal to negative 4.7. All right, we need the cosine to be by itself before we can apply the inverse. And so we're going to divide by 5, cancel the 5, divide by 5, and we get cosine of 3x is equal to negative 4.7 divided by 5. It's going to give us negative 0.94. Okay, now I can do cosine inverse to both sides, cosine inverse to both sides, cancel the cosine, carry down the 3x is cosine inverse of negative 0.94, divide by 3, and now we can key that in the calculator. Second cosine gives me cosine inverse of negative 0.94, close parenthesis, enter. Then I'm going to divide by 3, enter, and I get x is equal to 0.931. 0.931, okay, which is what I put on the review, the key for the review. All right, let's try question number 27. All right, question 27 is 2 sine of 7x minus 2. 2 sine of 7x minus 2 minus 1 is equal to negative 2.4. All right. So the first thing I'm going to do is I'm going to add 1 to both sides to cancel here. And now I have 2 sine of 7x minus 2 is equal to, add 1 is going to give us negative, it's an ugly equal sign, equals negative 1.4. Okay, because negative 2.4 plus 1 is negative 1.4. Now I'm going to divide by 2 on both sides to cancel this 2, divide by 2, and I get sine of 7x minus 2 is equal to, so we're going to do negative 1.4 divided by 2 is going to give us negative 0.7. Now to cancel this sine, we'll do sine inverse to both sides. Cancel the sine, carry down the 7x minus 2 is equal to sine inverse of negative 0.7. Now we're going to add 2 to both sides. Add 2, cancel. Divide by 7, cancel, divide by 7. And now x is going to be equal to sine inverse. So I'll hit second sine, so sine inverse of negative 0.7, close parenthesis, plus 2, enter. Divide by 7, divided by 7, gives me 0.174. 0.174, and that is the answer to question number 27. Okay. All right, now let's try question number 28. We're here. All right, 28 says 8 cosine of 2x minus 5 over 7. 2x minus 5 over 7 plus 11 is equal to 14. Plus 11 is equal to 14. All right, let's do some algebra. I need the cosine to be by itself. So I'm going to minus 11 from both sides. And I'm going to get 8 cosine of 2x minus 5 over 7 is equal to 14 minus 11 is 3. Then I'm going to divide by 8 on both sides. Okay, 3 divided by 8. That's 0.375. 0.375. So now I have cosine of 2x minus 5 over 7 is equal to 0.375. Now I need to get rid of the cosine, so I'm going to do cosine inverse to both sides. Cosine inverse is going to cancel cosine, and now I have 2x minus 5 over 7 is equal to cosine inverse. Actually, here's what I'm going to do. For this one, it's just going to be a lot easier because there's a lot of stuff to mess with over here. I'm going to go ahead and get a number here. Okay, so I'm going to go ahead and do cosine inverse of 0.375, and that gives me 1.186399, and the reason 552. The reason I'm writing out so many numbers is because I'm not at the end of the question. It would be very dangerous for me to round now and then do a whole bunch of additional math, because that rounding is going to carry itself forward, and the rounding will become larger and larger and larger in error. Okay, so I'm putting as many decimals as I can. So I'm going to multiply by 7 on both sides, multiply by 7, and I get 2x minus 5 equals. Now this number is still sitting in my calculator, so I can just hit times 7. And that's going to give me 8.304796,866. Okay, then I'm going to add 5 to both sides, add 5, okay, and that's going to cancel over here, so 2x is equal to, adding 5 just makes this, the decimal will be the same, but this will now become a 13.304796,866. Okay, so I'm going to add 5 in the calculator, so 13.304796,866, divide by 2 on both sides. See, it's the last thing, it's 2x equals, so divide by 2, and my answer is x equals, this one I can round, 6.652. 6.652, and that is question number 28, okay? All right, let's do question 29. Question 29 says, 4 sine of 3 over 2x, 4 sine of 3 over 2x minus 1 equals negative 4. So we're going to add 1 to both sides, and so we're going to have 4 sine of 3 over 2x, this cancels, is equal to negative 4 plus 1 is negative 3. Now we're going to divide by 4 on both sides, divide by 4, that's negative 0.75, right? So sine of 3 over 2x is equal to negative 0.75. Now we got to do sine inverse, because all we have left over here now is the sine function. So sine inverse of both sides, cancel. And now I'm going to have 3 over 2x is equal to sine inverse of negative 0.75. Now, this can get a little weird. I want to get rid of this denominator, so I have to multiply by 2x on both sides. Multiply by 2x on both sides. Cancel the denominator, and now I have 3 is equal to 2x times sine inverse of negative 0.75. Because I had to multiply both sides by 2x. Now the x is over on the right side. And now to get the x by itself, I'm going to divide by 2 sine inverse of negative 0.75. See what's going to happen here is when I divide by the 2, it cancels the 2. When I divide by the sine inverse, it's going to cancel the sine inverse, and all that's going to be left is that x right there. So if I divide by this on this side, I have to divide by the same thing on the left side. I've got to divide by 2 sine inverse of negative 0.75. That's going to cancel the 2 over here, cancel the sine over here, and now all I have left on the right side is x equals, and now I'm going to key this in the calculator. 3 divided by, and I'm going to put parentheses, 2 times sine, parenthesis, putting this whole thing in parenthesis. 2 sine inverse of negative 0.75, close the parenthesis on the sine inverse, close the parenthesis on the denominator, press enter, and I get negative 1.768. Negative 1.768 is my answer for x. Okay. Now, bear in mind, any one of these answers that you get, you can just take it and go back to the original question and key it in for x, and you should get this answer over here. So you can check your answers. Okay. All right, let's come back over here. We're going to do question number 30 now, the last one of these. Question number 30. 30 is 6 cosine of pi x minus 2 is equal to 1. All right, so first thing I'm going to do is I'm going to add 2 to both sides, cancel, and I get 6 cosine of pi x. Remember, pi is just a number. This could just as easily be 2x, 3x, 4x, 5x, but it's pi x equals 1 plus 2 is 3. Now we're going to divide by 6 on both sides, divide by 6, and I get cosine of pi x is equal to 3/6. Isn't that the same thing as 1/2 is equal to 1/2? Now all I have left on the left is cosine. So I'm going to do cosine inverse of this, cancel the cosine. Now I have pi x is equal to cosine inverse of 1/2. Now I want to stop for a second. I want to show you something. We actually don't need the calculator for this one. We can actually do cosine inverse of 1/2. In fact, it's very similar to one of the ones that we did up in questions 16 to 23. I know what cosine inverse of 1/2 is. The x coordinate is 1/2 at the angle measure pi over 3. And so what we have here now is pi x is equal to pi over 3. Now if you did it in the calculator, you'd probably get 1 point something, and that's fine. But I just want to show you that sometimes you can actually solve these equations by using the radian measures from the unit circle. Now what we're going to do is we're going to divide by pi on both sides. So dividing by pi over here is going to cancel pi, leaving x. Dividing by pi is the same thing as multiplying by 1 over pi. And watch what this is now going to become. The pi's are going to cancel each other. Or let's go ahead and work it out. Pi times 1 is pi. Over 3 times pi is 3 pi. Now the pi's are going to cancel each other, leaving a 1 up top. And now x is equal to 1 over 3, or 1/3. Now if you had done it with the calculator correctly, you would have gotten x is equal to 0.333333 repeating. And that's question number 30. Okay? All right, that's the first page of the review. Let's now move on to the second page. All right, now let's continue with question 31. I'm going to go ahead and project up here our table of values. We've got f of x, g of x, h of x, and k of x, right? We've got x is equal to. We've got questions 31 through 37 here that all refer back to this mega table, okay? Or magna table, whatever you want to call it, okay? All right, so we have f of g of 4. So in order to identify f of g of 4, I first need g of 4. So I need g of 4. So g at 4 is 8. So this is the same thing as what is f of 8? Well, that's easy to find. F of 8 is 10. Therefore, the answer to question 31 is 10. All right, 32, we want g of k of -1. So we need k of -1 first. -1, k is the bottom row, so k of -1 is 2. So this is the same thing as what is g of 2. G of 2, go to g is 5. And there's the answer to question 32. All right, question 33, h of f of 0. So first we need the answer to f of 0. F of 0, f is the first row, so 0. F of 0 is 5, so we need h of 5. And now let's go to the 5. H is the third row, that's -7, so the answer to 33 is -7. Question 34, this one's a little harder. H of k of f of 9. So we've got to work from inside out. Let's find f of 9 first. Go over to 9. F of x at 9 is 5. And so what this is now asking for is h of k of f of 9 is 5, so it's k of 5. Now this looks like question number 31. K of 5, k is the bottom row. Here's 5, so it's 1. So what we're really asking for here is what is h of 1. Now we'll go to 1, go to the third row, which is h, which is 3, and we're done with question number 34. 35, k of g of h of 6. Well, let's find h of 6 first. 6 is here, h is the third row, -1. So now what we want is k of g of -1. G of -1, we're going to go to -1. G is the second row, that's 0. So we want k of 0. K of 0, the fourth row, is -23, and therefore the answer to question number 35 is -23. All right, question 36 says f of g of -2. That's weird. We haven't seen that yet, have we? G of g? Okay, that's okay. We can still do this. We're going to start on the inside, g of -2. Let's just go to -2. G is the second row. That's 3. So it's asking for f of g of 3. G of 3, here's g, is 7. So what we really want is f of 7. F of 7, top row of x equals 7, is 13. And so the answer to question number 36 is 13. Now this 37, this crazy bear, m of x is equal to this crazy looking thing, x squared. And we want to know what m of 3 is. So we're going to plug 3 in for all the x's. So we're going to put a 3 in here for x squared. So that's 3 squared plus g of f of x plus g of f, but not of x, of 3, right? Plus f of k of h plus f of k of h, not of x, of 3, okay? So this is really what we're looking for. Now let's try and figure out these two here first. G of f of 3. F of 3 is 0. So really what we're looking for here is g of 0, okay? G of 0 is 17. So this number, and 3 squared, that's 9. So this is a 9, this is a 17 plus f of k of h of 3. Let's work inside out. H of 3 first. Here's 3. H is the third row. That's a 6. So this is f of k of 6. K of 6, let's go to 6. K is the third row, is 5. So really what we need here is f of 5. So we'll go to 5. First row is f of x. So this is 12, so plus 12. So it's 9 plus 17 plus 12. 9 plus 17 is 26. 26 plus 12 is 38, and so the answer to question number 37 is 38. Okay, so that's questions 31 through 37. All right, let's go ahead and scroll down here, and we'll work on questions 39, 38, 39, and 40, because we got to refer back to these other functions here. It says here that f of x is x cubed minus x, g of x is 3 to the x power, h of x is 24 over x minus 3, and k of x is 2x plus 5. And what this says is, if n of x is the same thing as g of k of x, then what is n of x as an analytical function? Okay, n of x. Here's what I recommend doing. Write the outside function first. So g of x, which is 3 to the x power. But in place of the x, write the inside function, which is k of x. So instead of 3 to the x power, we're going to write 3 to the power of k of x. Now we're going to rewrite it again. It's going to be 3 to the power of whatever k of x is. 3 to the power of, well, k of x is 2x plus 5. So it's 3 to the power of 2x plus 5, and this is g of k of x. Now we want to know what n of 1 is. N of 1 is going to be 3 to the power of 2x plus 5, but we're going to put a 1 in for the x. So it's 3 to the power of 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7, so this is 3 to the 7th power. And 3 to the 7th power, I'm going to need a calculator for that one. Let's see here. 3 to the power of 7, that's 2,187. And that's the answer to the second part of question 38. All right, let's now look at question 39. It says p of x is h of f of x. So what is p of x as an analytical function? So p of x is going to be, here's what we're going to do. We're going to write the outside function h. So h is 24 over x minus 3. 24 over, instead of x minus 3, we're going to write whatever's on the inside of this composition function. We're going to write f of x. So f of x minus 3. So p of x is 24 over f of x minus 3. Well, now we can rewrite that again, only in place of f of x, we'll put what f of x is, which is x cubed minus x. So we're going to write x cubed minus x and then a minus 3. And this, what you're looking at, is p of x. Now we want to know what p of 2 is. For p of 2, we're going to rewrite p of x, but instead of x's, we're going to put 2's in for x's. So we're going to go 24 over 2 cubed minus 2, in parentheses, minus 3. And now, 24 over 2 cubed, 2 times 2 times 2, that's 8. So we got 8 minus 2 minus 3. So now we have 24 over, 8 minus 2 is 6, 6 minus 3 is 3, so it's 24 over 3, which is 8, and that is the answer to the second part of question 39. Now let's move on to question 40. It says w of x is equal to f of k of x. So now what we want to do is we want to write the outside function f of x, which is x cubed minus x. But everywhere we see an x, we want to put in k of x. And so we're going to do k of x cubed minus k of x. So k of x cubed minus k of x. K of x is 2x plus 5. So now in parentheses, I'm going to put 2x plus 5 cubed minus 2x plus 5. Now, here's the thing. This could be the final answer, but if I ask you to expand this polynomial into its standard form, what you're now going to have to do is you're going to have to expand 2x plus 5 times 2x plus 5 plus 2 times 2x plus 5. And so we got 2x plus 5 times 2x plus 5 times 2x plus 5. This is sort of crazy. I'm going to do 2x times 2x is 4x squared. 2x times 5 is 10x. 5 times 2x is another 10x. And 5 times 5 is 25. And now, if I combine the middle, I get 4x squared plus 20x plus 25 in parentheses. Why in parentheses? Because I still have to multiply that by 2x plus 5 again. And now, 2x times 4x squared is 8x cubed. 2x times 20x is 40x squared. And 2x times 25 is 50x. Now, 5 times 4x squared is 20x squared. 5 times 20x is 100x. And 5 times 25 is 125. Now I need to combine my x squares. So I'll put my 8x cubed first. 40x squared plus 20x squared is 60x squared. Now I got to combine my x to the first powers. 50x plus 100x is 150x plus 125. This is just this part. Now we have to subtract 2x plus 5. So we got to subtract. Now we got to distribute the negative. Minus 2x minus 5. So over here we're going to minus 2x minus 5. So now 8, so it's going to be equal to 8x cubed. Okay, that's good. Plus 60x squared. Now we have 150x minus 2x. Okay, and that's going to be plus 148x. And then we have 125 minus 5. So that's going to be plus 120. And so this is actually what w of x is equal to. And now we want to know what w of 3 is. Okay, we're going to put a 3 here, a 3 here, and a 3 here. 3 cubed is 27. 27 times 8. 8 times 27. That's 216. Now, 3 squared, that's 9. 9 times 60, that's 540. Then 148 times 3, that's 444. And then plus 120. Add all these up. 216 plus 540 plus 444 plus 120 is 1,320. 1,320. And that is the answer to w of 3. And we're done with question number 40. Okay? All right, now let's move on down to plotting polar coordinates. Scroll down. We're going to plot these in different colors because the review sheet says to plot them each in different colors. And I mostly did that so that you could understand my review sheet so that you can see which answers are which. All right, so here we go. Here's our polar coordinate grid. We're going to plot 5 and 5 pi over 3 in blue. So let me get blue here. So radius of 5 at the angle 5 pi over 3. Well, the angle 5 pi over 3 is right here. That's along this line right here. Radius of 5 is right here. So that is question number 41. Okay, that's in blue. Now in red, we're going to do 2 and pi over 6. Well, the angle pi over 6 is right here, this line coming out. Okay, and the radius is 2. So that's these circles are, that's 1, that's 2. So this point right here, that is 2 and pi over 6. That's question number 42. All right, now in green, let's do 6 and 3 pi over 4. Well, the angle 3 pi over 4 is right here. We can't see it. It doesn't say 3 pi over 4, but we know 3 pi over 4 is kind of halfway between 2 pi over 3 and 5 pi over 6. And we want a radius of 6, which is out here. This is a radius of 1, 2, 3, 4, 5, 6. There's a radius of 6. So put a green dot there. That's question number 43. Now we're going to plot, let's see here, we're going to plot 1 and 7 pi over 6 in black. 7 pi over 6 is right here, and the radius of 1 is right there. Radius of 1. So that's question number 44. Okay. And now question number 45 is going to be done in orange. Grab an orange marker. 11 pi over 6 and a radius of 3. So 11 pi over 6 is right here. Radius of 3 is 1, 2, 3. So 11 pi over 6, radius of 3 is right there. That's question number 45. And now the last one in purple is going to be 4. Radius of 4, angle measure of 2 pi over 3. 2 pi over 3 is right here. Radius of 4 would be 1, 2, 3, 4. That's right here. And that's going to be question number 46. So what we've done here is we've plotted 6 polar coordinate points on a polar grid. Okay. All right, now let's move on to the last page of the review, page 3. All right, page 3 of the review, questions 47, 48, and 49 ask us to convert polar coordinates into rectangular coordinates. All right, I want to remind you then that the rectangular coordinate x is equal to r times cosine of theta, and that the y coordinate is equal to r times sine of theta. Okay? And now we're given the coordinate for question number 47. We're given the coordinate 2 and 5 pi over 6. All right? And so what we want to do is, this is a radius, this is an r, right? And this is a theta. So to get the x coordinate, we just need to plug the r in for the r over there, and the theta, this, into the theta over there. So the radius is 2. So we're going to put a 2 in for r, and then cosine of 5 pi over 6. Cosine of 5 pi over 6. Maybe we do need the unit circle here. So look at a unit circle, and I can tell you that cosine of 5 pi over 6, so x equals cosine of 5 pi over 6 is going to be square root of 3 over 2. So this is, negative square root of 3 over 2. So this is going to be 2 times negative square root of 3 over 2. And then that's going to be negative 2 square root of 3 over 2, and therefore the 2's are going to cancel, and so our x coordinate is going to be negative square root of 3. Now for our y coordinate, we're going to use r sine of theta. R is 2 sine of theta, 5 pi over 6, and 5 pi sine of 5 pi over 6, that's 1/2. And so we're going to have y is equal to 2 times 1/2, and 2 times 1/2 is 1. And therefore y is equal to 1, and therefore the rectangular coordinates that are equal to the polar coordinates 2 and 5 pi over 6 are negative square root of 3, comma 1, and that point is on the rectangular coordinate is in the exact same place as that point on the polar grid. Okay. All right, let's do question number 48 now. 48 gives us the coordinate 3 and 7 pi over 4. 3 and 7 pi over 4. Okay, so x is going to be equal to 3, the radius, times cosine of the theta, 7 pi over 4. All right, and so x is equal to 3 times cosine of 7 pi over 4. This is in the fourth quadrant, and over 4, that makes it square root of 2 over 2. And so that's going to be 3 square root of 2 over 2. Y is equal to 3 times sine of 7 pi over 4. And so y is going to be equal to 3 times, now sine of 7 pi over 4 in the fourth quadrant is negative square root of 2 over 2. And that's going to give us negative 3 square root of 2 over 2. And so our rectangular coordinates are 3 square root of 2 over 2 and negative 3 square root of 2 over 2. And we are done with question 48. And now question 49. We are given the point 7 and 4 pi over 3, radius 7, theta angle 4 pi over 3. And so our x coordinate is going to be 7. Looking over there. 7 times cosine of 4 pi over 3. And so x is going to be equal to 7 times cosine of 4 pi over 3. That's in the third quadrant. And the cosine is going to be negative 1/2. So negative 1/2. So our x-coordinate is going to be negative 7 over 2 or negative 3.5. Okay? And our y-coordinate is going to be 7 times sine of 4 pi over 3. And so our y-coordinate is 7 times sine of 4 pi over 3 in the third quadrant, so it's negative. It's going to be negative square root of 3 over 2. And so our y-coordinate is negative 7 square root of 3 over 2. And so our rectangular coordinates that match those polar coordinates are negative 7 over 2, comma, negative 7 square root of 3 over 2. And that is that's our rectangular coordinate for question 49. Okay? All right, so now questions 50, 51, and 52, those questions are asking us to go the other way around. We start with a rectangular coordinate and we want to identify the polar coordinates. Well, we can use the exact same things here. Instead of going from r and theta over to x and y, we're going to go from x and y over to r and theta. Okay? Now the good news on this one is you actually only have to do one of them. You don't have to do both of them because both of them have r and theta in them. So really, you really only need you need to do either x or y. We're going to do x in all of them. Or maybe I'll do x in one of them and y in the other one. The hard part about this one is that you have to determine, so like question 50, you're given 1 and 3. So question 50, rectangular coordinates 1 and 3, we want to know the polar coordinates of the same location on the coordinate plane. Now the problem is that we're trying to go from an x over to an r and a theta. Well, we can't get an r and a theta from one number here. So we need to also calculate the radius, and if you recall, the radius is equal to the square root of x squared plus y squared. It's based on the Pythagorean theorem, because a radius is basically a hypotenuse, and therefore r squared is equal to x squared plus y squared. These are your a and your b, this is your c. We do the square root of both sides, and we get our radius is equal to the square root of x squared plus y squared. So in every one of these, the first thing we should do is identify the radius. So the radius is going to be equal to the square root of x squared, that's 1 squared, plus y squared, that's 3 squared. So 1 squared plus 3 squared. 1 squared is 1, 3 squared is 9, and so 1 plus 9 is 10, so the radius is the square root of 10. So now we have the radius, now we can identify the theta. So let's do y in this case. I did x on the review sheet. I'll do y in this video. So we'll use y is equal to r sine of theta. Okay? So the y is 3, radius is square root of 10, and then sine of theta. So the first thing we're going to do is divide by the square root of 10 on both sides. Divide by the square root of 10. And now, doesn't this look a lot like one of the questions on the first page where we had to solve using a calculator? And so we are going to solve using a calculator, and we want to make sure that our calculator is in radian mode. So make sure your calculator is in radian mode. Mine says rad at the bottom here, so I know that it's in radian mode. So I'm dividing by the square root of 10, and now I get sine of theta over here, sine of theta, I switched it around, is equal to 3. Actually, maybe I'll just leave it the other way. I'll leave it like this. So I know that 3 over the square root of 10 is equal to sine of theta. Now, to solve for theta, I need to do sine inverse of both sides. Sine inverse of this. So now theta is going to be equal to sine inverse of 3 over the square root of 10. So now I'm going to do sine inverse of 3 divided by the square root of 10. And that's going to give me theta is equal to 1.249. 1.249. It's okay that it's not in pi. We could put this in pi, but I'm not going to make you do that. Okay? So now our radius is square root of 10. Our theta is 1.249. So our polar coordinate is going to be the square root of 10, comma, 1.249. And there is our polar coordinate that is in the exact same place as the rectangular coordinate 1, 3. All right, let's do question 51. 51 says our rectangular coordinates are negative 4 and 5. Negative 4 and 5. And I'm going to use, let's use x this time. So let's find our radius first. R is equal to the square root of x squared. So I'm going to put negative 4 in parentheses, squared, plus y squared, 5 squared. Okay, and so that's going to be, well, let's go vertically here. So now r is going to be equal to the square root of -4 times -4 is 16, plus 5 squared is 25. And so 16 plus 25, that's 41. So the square root of 41. So the radius is the square root of 41. And now we can do x is equal to r times cosine of theta. Our x coordinate is -4 equals radius is the square root of 41 times cosine of theta. So we're going to divide by the square root of 41 on both sides. Cancel. Divide by the square root of 41 on both sides. And we get -4 over the square root of 41 is equal to cosine of theta. Cancel cosine with a cosine inverse. Cancel. We'll also do cosine inverse over here. So theta is going to be equal to cosine inverse of -4 over the square root of 41. I can do that in a calculator. Second cosine gives me cosine inverse. -4 divided by square root of 41. Square root of 41. And then I'm going to get 2.245. 2.245 is equal to theta. And so our radius is square root of 41. Our theta is 2.245. So our polar coordinates are square root of 41, comma, 2.245. Moving on to the next question. All right, last one on this one. 52. Our rectangular coordinates are 2 and -3. We need our radius. So the radius is going to be the square root of 2 squared plus -3 squared. So the radius is going to be equal to the square root of 2 squared is 4 plus -3 squared is 9. So that's the square root. 4 plus 9 is 13. So our radius is the square root of 13. Let's use y again this time. Y is going to be equal to radius times sine of theta. So y is equal to the radius is the square root of 13. Oh, excuse me. Y is -3. All right, so -3 equals the square root of 13 times sine of theta. Once again, we're going to divide by the radius on both sides, square root of 13. Cancel that. So sine of theta is going to be equal to -3 over the square root of 13. Cancel the sine so we can solve for theta by doing sine inverse. Cancel sine inverse of this. And now we can do sine inverse of -3 over the square root of 13. So sine inverse of -3 divided by the square root of 13. And I get theta is now equal to -0.982. Okay, and so here's our theta, here's our radius, and so our polar coordinate is going to be the square root of 13, comma, -0.982. And that is question number 52. All right, so we're done with converting rectangular coordinates into polar coordinates. Now, let's do questions 53 through 55. Now, for this particular exam, I want to skip 53. And you'll see that on the review sheet that I said to skip it, okay? It's a little more challenging than I thought it would be, and so I don't want you to have to be bothered with it because it's a little more challenging than I thought it would be. And so let's just do questions 54 and 55, okay? You'll see a question just like 54 on the exam, and you'll see a question just like 55 on the exam. Let's put 55 over here. Okay, so 54 is y is equal to the square root of 25, is that right, minus x squared. All right, so this is a function in rectangular form. We want to turn this function into a polar function, well, not function, a polar relation, okay, in polar form. So in order to do that, what we're going to do is we need to replace our y with what y is equal to in polar form, and we're going to replace our x with what x is equal to in polar form. So y is r sine theta, so we're going to put r sine theta is equal to big square root here, 25 minus, and now instead of x squared, we're going to do r cosine of theta squared. So r, I got to put it in parentheses, r cosine of theta, that's x squared. Now, when we square r cosine of theta, it's actually going to distribute onto the r and onto the cosine. And so what we're going to have now is r times sine of theta is equal to big square root here, 25 minus r squared times cosine squared of theta. Okay? And so now we can start solving algebraically. I got to get rid of this square root because the square root is all by itself. So on both sides, I'm going to square. Both sides, I'm going to square. And so over here, I'm going to have r squared sine squared of theta is equal to, cancel the square root, 25 minus r squared cosine squared of theta. Now, I want to move all of the r's, every term that has an r in it, I want to move it to the left, and every term that doesn't have an r, I want to move it to the right. Well, this is the only term that doesn't have an r. It's already on the right, but this one has an r in it, and it's on the right. I got to move it to the left. So I'm going to add r squared cosine squared of theta to both sides. Add r squared cosine squared of theta to both sides. Cancel on the left, cancel on the right. Over here on the left is going to be r squared times sine squared of theta plus r squared times cosine squared of theta is equal to, all that's left over here on the right is 25. After I move all my terms with r's in them to the same side, now I factor out all of the r's from the left side. So this has an r squared and this has an r squared. So I'm going to factor an r squared out of this. And so I'm going to have r squared, then a parenthesis, sine squared of theta plus cosine squared of theta is equal to 25, right? Now, I want to remind you of something. Didn't you learn just a couple days ago one of the identities, that sine squared plus cosine squared is equal to 1? Sine squared plus cosine squared, isn't that equal to 1? Therefore, this auto cancels. It's automatically 1. Therefore, r squared times 1 is just r squared. And now all we have is r squared is equal to 25. To solve for r, I'm going to do the square root of both sides. Now, you would think that the answer would be plus or minus 5. Okay? But really, the answer is going to be 5 because a radius, well, it has to be positive. Technically, it doesn't have to be positive analytically, but it has to be positive. And so in this case, the radius, the answer is r equals 5. And you might say, but where's the theta? The theta canceled. This is kind of like having a constant function. This is a polar relationship where the only thing that characterizes it is that the radius is 5. And what this is going to draw is a perfect circle with a radius of 5. Okay? I think that's pretty cool. All right, question 55 now is y equals 3x plus 7. Y equals 3x plus 7. Replace the y with r sine theta. So r sine theta is equal to 3 times, replace the x with r cosine theta plus 7. Okay, good. Now, move all the terms that have an r in them over to the left. Anything that doesn't have an r goes to the right. The 7 is already on the right. Let's move this over to the left. We're going to subtract 3r cosine theta. Over here, we're going to subtract 3r cosine theta. On the right, we're going to cancel it. And over here, we're going to have r sine of theta minus 3r cosine theta is equal to, all that's left over here on the right is 7. Now we're going to factor the r's out. There's one r here, r to the first, and r to the first here. Factor those out. So we're going to have r times sine of theta minus 3 cosine of theta, factored out the r, right, is equal to 7. One step remaining. Divide by sine of theta minus 3 cosine of theta, and that'll get the r by itself, because that's our goal. We want it to be r equals. Over here, we're going to divide by sine theta minus 3 cosine theta, and here's what we wind up with. This cancels. R equals 7 over sine of theta minus 3 cosine theta. And therefore, this is the equation the final answer for question number 55. Okay? All right, let's go on to 56. Okay, 56, 57, 58, 59, 60, and 61. They all say circle the identities that are true. Okay? And so when we look at these 6, I'm going to tell you right now, 3 of them are true and 3 of them are false. And so I may need this, but I'm going to go ahead and erase these. We don't need those anymore. Okay? What I am going to write up here is we got sine squared plus cosine squared is equal to 1. Let me get our paper, our identities here. I also want to remind you that secant squared, okay, and I'm going to, this is supposed to be, I'm going to put an x here. So sine squared of x plus cosine squared of x is equal to 1. So secant squared of x is equal to tangent squared of x plus 1. And cosecant squared of x is equal to 1 plus cotangent squared of x. Okay? And so these are 3 of the identities that we may need. I think they're the only identities that well, plus the reciprocal identities and the quotient identities. Okay? All right, let's go to 56. Basically, we're just trying to identify which ones are true and which ones are false. The first one says cosine of x times tangent of x is equal to sine of x. Now again, we're not going to change the right side, we're only changing the left side. So tangent of x, we'll have cosine of x times, tangent is the same thing as sine of x over cosine of x, right? And so look, we can cancel cosine of x, top and bottom, and all we have left is sine of x, and sure enough, sine of x is equal to sine of x. Therefore, 56, that one is true. 57 over here, we've got sine tangent equals cosine. Sine of x times tangent of x is equal to cosine of x. We'll leave sine of x. We're going to convert tangent into sine of x over cosine of x. Okay, well, we're not changing the right side, so let's leave this. Now here, sine of x times sine of x, that gives us sine squared of x over cosine of x. In order for all this to be equal to cosine of x, we would need cosine to be on the top and we'd need the sines to cancel, and they're not doing that. And therefore, this is not equal to cosine of x, and therefore, 57 is false. Let's go to 58. 58 says cosine of x over cosecant of x minus sine squared of x times cosecant of x, okay, that's crazy looking, right, is equal to secant squared of x minus 1. Now, I want to show you this secant squared of x minus 1. If we come over here, do you see the secant squared of x is equal to tangent squared of x plus 1? If I was to subtract 1 here and here, I would have secant squared of x minus 1. And therefore, so I'm going to rewrite this. Secant squared of x is equal to tangent squared of x plus 1. If I subtract 1 here and subtract 1 here, the 1 is going to cancel over here. And over here, I'll have secant squared of x minus 1 is equal to tangent squared of x. So in order for this to be true, this would have to be equal to tangent squared of x. We would have to wind up with tangent squared of x over here on the left. And let's see if that happens, okay? All right, the top is going to stay cosine of x. But look at the denominator here. Do you see how there's a cosecant of x and a cosecant of x? I can factor out cosecant of x because it's a greatest common factor. So I'm going to factor out a cosecant of x. And what that's going to leave is this is going to be a 1, because so cosecant of x divided by cosecant of x is 1, minus, the only thing that's going to be left here is sine squared of x. So I'm going to have 1 minus sine squared of x, right? Now watch this. See this 1 minus sine squared of x? If we come over here to sine squared plus cosine squared equals 1, if I subtract sine squared of x, over here I get 1 minus sine squared of x, and all I have over here is cosine squared of x. And therefore, this is actually equal to cosine squared of x. So I can rewrite this as cosine of x over cosecant of x times cosine squared of x, right? Now, also, cosecant of x, I'm going to move the cosecant of x outside of the fraction. I'm going to make it 1 over cosecant of x times cosine of x over cosine squared of x, right? And isn't 1 over cosecant of x the same thing as sine of x? So now I have sine of x times, over here, I have one cosine up top and 2 cosines in the bottom. I can cancel one of the cosine. One of the cosines in the top, and then, one of the cosines in the bottom, just by getting rid of this, and all I have left in the bottom now is 1 cosine. So I now have sine of x, and I have a 1 up top here, and a cosine in the bottom, 1 over cosine of x. Sine of x times 1 over cosine of x. The sine of x is going to go into the numerator, and I'm going to have sine of x over cosine of x, which is the same thing as tangent of x, but guess what it's not? It is not tangent squared of x, and therefore it is not equal to secant squared of x minus 1. Therefore, 58 is false, not circled. Okay? All right. Let's now try number 59. We've got cosine of x, tangent of x, over sine cosecant secant, sine cosecant secant is equal to sine cosine. Sine of x, cosine of x. Now, first thing I want to show you is that cosecant is 1 over sine, right? And tangent is sine over cosine. So here's what I'm going to do here. Cosine of x times sine of x over cosine of x over sine of x times 1 over sine of x. And then secant is 1 over cosine of x, right? And so here's what I have. In the numerator, we have cosine is going to cancel with the cosine of x in the denominator. So all I have left in the numerator is sine. Here, sine of x is going to cancel with 1 over sine of x, because sine of x times 1 over sine of x is sine of x over sine of x, which is 1. That cancels. And now all I have left is sine of x over 1 over cosine of x. Well, if I rewrite this, I can rewrite it as sine of x divided by 1 over cosine of x. If I divide by a fraction, this is a keep, change, flip situation. So keep, sine of x, change to multiply, flip. If I flip 1 over cosine of x, I just get cosine of x, which is sine of x cosine of x. So this is equal to sine of x times cosine of x, making this one true. Okay? So 59 is true. And now let's move on to 60. Okay? And in 60, we have cosecant squared of x plus cotangent squared of x is equal to sine squared of x plus cosine squared of x. Now, we know that sine squared of x plus cosine squared of x is equal to 1. So we want to see if cosecant squared of x plus cotangent squared of x is equal to 1. So we can just go over here to, I messed this up a long time ago. This is supposed to be cosecant. Man, Mr. Ryan, what is wrong with you? Cosecant squared of x is equal. So let's go over here and see if we can get the same thing. I want to solve for 1 here. Okay, I need it to be equal to 1. I need 1 by itself because over here I know sine squared plus cosine squared is equal to 1. So I'm going to subtract cotangent squared of x from both sides. And when I do, it's going to cancel on the left, and I'm going to have equals 1. And I'm going to have cosecant squared of x minus cotangent squared of x, which does not equal, this is not the same thing as this. This is cosecant squared plus cotangent squared. So this must not be true. But let's go ahead and prove it. Let's make this 1 over sine squared of x plus, this is going to be cosine squared of x over sine squared of x. And now we have a common denominator, so we're going to add the numerators together. 1 plus cosine squared of x over sine squared of x. Okay? And now what this is going to become is, this would be true if the numerator was equal to sine. So if this is equal to sine, or sine squared, then sine squared divided by sine squared would be 1, which is equal to sine squared plus cosine squared. But here's the problem, is that this numerator is not 1. 1 plus cosine squared, if we put the cosine with the 1, we would say that sine squared of x is not equal to 1 plus. We would have to subtract cosine squared. It would be 1 minus cosine squared of x. So if this said 1 minus cosine squared of x, then we could then replace this with sine squared of x, and we'd have sine squared over sine squared, and that would equal 1, and that would mean 1 is equal to sine squared plus cosine squared, and that would be true. But it's not. Therefore, this is not true. We will not circle number 60. The last one we're going to do is question 61, which is sine squared of x over 1 plus cosine of x is equal to 1 minus cosine of x. Now, when you're handling an identity like this, do you see how the denominator is a sum of two values? One of the things that you can do here is a technique where you multiply by the conjugate. So we can multiply the top and the bottom by 1 minus cosine of x. So we're going to do 1 minus cosine of x over 1 minus cosine of x times sine squared of x over 1 plus cosine of x. Now, in the denominator, this is going to become a difference of squares. This is kind of like, x minus 5 and x plus 5. And that would become x squared minus 25. It would be the square of the first one minus the square of the second one. So the denominator here is going to be 1 minus cosine squared of x. Now we have to multiply 1 minus cosine of x times sine squared of x. We got to distribute the sine squared of x to both of these over here. Sine squared of x times 1 is sine squared of x minus sine squared of x times cosine of x is just simply sine squared of x times cosine of x. And so now, before, over in this problem, 1 plus cosine squared, we said that's not equal to sine squared of x, right? It has to be 1 minus cosine squared, which is exactly what we have in the denominator here, okay? And so, actually, I'm going to go backwards. I don't want to distribute this sine squared. This is actually going to become perfect for us. I'm going to leave this as 1 minus cosine of x times sine squared of x. And watch this. This denominator is equal to sine squared of x. So I'm going to cancel that and make it sine squared of x. Now look what we have. 1 minus cosine of x times sine squared of x over sine squared of x. We can cancel the sine squared of x, and all we have left is 1 minus cosine of x, which is what we started with. And so therefore this is true. This is equal to this. And so 56 is true, 59 and 61 are true, 57, 58, and 60 are all false. Okay? All right. Let's now do this last part, or two more parts, 62 and 60, 62, 63, 64, and 65. These require you to use a couple of the identities. They're called for these you're going to use the sum and difference formulas on the identity sheet. The sum and difference formulas on the identity sheet. Okay? And so, here's how we're going to work these out. Question number 62 says that we want to know what is sine of 75 degrees. Now, this is not one of the normal angles on the unit circle. Okay? So what we're going to do is we're going to turn sine of 75 degrees into sine of 45 degrees plus 30 degrees. Here's why. Because 45 degrees, that's the same thing as pi over 4. 30 degrees is the same thing as pi over 6. These actually are on the unit circle. Okay, and so we're going to do these questions. It says use sum and difference formulas as well as what you know about the unit circle to evaluate these. We're not going to use a calculator to answer these. But there's a formula that says sine, let's see, it says sine of, the formula says sine of alpha plus beta, let's just say a plus b, sine of a plus b is equal to sine of a times cosine of b plus sine of b times cosine of a. And so here's what we're going to do to be able to calculate this sine of 45 plus 30. We're going to do, this is going to be a, and this is going to be b. So we're going to do sine of a, sine of 45, so sine of 45 degrees, times cosine of 30 degrees, plus sine of b, which is 30 degrees, times cosine of a, which is 45 degrees. Okay? And we have all this stuff is on the unit circle. 45 degrees is the same thing as pi over 4. So sine of pi over 4 is square root of 2 over 2. Cosine of 30 degrees is pi over 6. Cosine of pi over 6 is square root of 3 over 2, plus sine of pi over 6 is 1/2 times cosine of pi over 4 is square root of 2 over 2. And now square root of 2 times square root of 3, that's square root of 6 over 2 times 2 is 4 plus 1 times square root of 2 is square root of 2. 2 times 2 is 4. Common denominator, the answer is square root of 6 plus square root of 2 over common denominator 4. So the answer to this is sine of 75 degrees is square root of 6 plus square root of 2 over 4. Now, question number 63 is asking something very similar. It says, what is cosine of 75 degrees? We're going to break that up into cosine of 45 degrees plus 30 degrees. And we're going to use our formula. Our cosine formula says cosine of alpha plus beta, or a plus b. Cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. Okay? So to find cosine of 75, which is 45 plus 30, 45 plus 30, a is going to be 45, b is going to be 30 again. So we're going to do cosine of a, so that's cosine of 45, times cosine of b, that's cosine of 30, minus sine of a, which is 45, times sine of b, which is 30. Cos 45 degrees is pi over 4. Cosine of pi over 4 is square root of 2 over 2 times cosine of pi over 6, that's square root of 3 over 2, minus sine of pi over 4 is square root of 2 over 2. Sine of pi over 6, that's 1/2. And so we have square root of 2 times square root of 3 is the square root of 6. 2 times 2 is 4 minus square root of 2 times 1 is square root of 2. 2 times 2 is 4. And now common denominator is 4. Square root of 6 minus square root of 2. And so this one is square root of 6 minus square root of 2, where this one is square root of 6 plus square root of 2. So cosine of 75 degrees is square root of 6 minus square root of 2 over 4. Okay? Now let's do questions 64 and 65. Let's actually keep our formulas here. Sine. Now it's going to be, let me show you this. Keep our formulas. Now it's sine of 15 degrees. 15 is 45 minus 30. And so we want to use our subtraction formula, which is sine of A times cosine of B minus sine of B times cosine of A. Cosine, this is going to be for question number 65. So this is 64. This one is 65. Okay. Cosine of 15 degrees, and that is 45 minus 30. So A is going to be 45 and B is going to be 30. And cosine of A minus B is cosine plus sine times sine. Okay? And that's right off of our identity sheet. Okay? And so sine of 15, which is 45 minus 30, is going to be sine of A, which is 45 degrees, times cosine of B, which is 30 degrees, minus sine of B, which is 30 degrees, times cosine of A, which is 45 degrees. Sine of pi over 4, square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2, minus sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. And so square root of 2 times square root of 3 is square root of 6 over 2 times 2 is 4 minus 1 times square root of 2 is square root of 2. 2 times 2 is 4. Common denominator of 4. Square root of 6 minus square root of 2 is square root of 6 minus square root of 2. And this is the correct answer to question number 64. Now 65 is going to be, here's our formula. A is 45, B is 30. So we're going to have cosine of 45 degrees times cosine of 30 degrees, 30 degrees, plus sine of 30 degrees, or excuse me, that's 45. Sine of 45 times sine of B, which is 30 degrees, cosine of pi over 4, that's square root of 2 over 2. Cosine of pi over 6, that's square root of 3 over 2, plus sine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4, plus square root of 2 times 1 is square root of 2. 2 times 2 is 4. Again, common denominator over 4. Square root of 6 plus square root of 2 is square root of 6 plus square root of 2. And that's the answer to question number 65. Okay? All right. You guys are rocking through this. Last couple questions, 66 through 69. This is what we did on the very last day, which was lines and average rate of change. So everybody seemed to be pretty okay with this. So hopefully you guys caught on to this pretty good. Number 66 says, what is the equation of a line that has a slope of 5, so m is 5, passes through the point -8 and -15? Okay? All right? So we're going to put it in, I want point slope form and slope intercept form. So in point slope form, we're going to do y minus y1, y minus a y coordinate. The y coordinate is -15. So y minus -15 becomes y plus 15 equals slope, which is 5, times x minus the x coordinate, which is -8. X minus -8 is x plus 8. This is slope intercept form. We're done with slope intercept form. Now we're going to turn it into, this is point slope form. And we're going to turn this into slope intercept form. So we got y plus 15 equals, I'm going to distribute the 5x, 5 times 8 is 40. So 5x plus 40. Then we're going to subtract 15 from both sides. And we get y is equal to 5x plus 25. There's our slope intercept form. There's our point slope form for question 66. 67, do the same thing for slope of -3 passing through the point 413. 4, 13. So y minus the y coordinate 13 is equal to slope, -3, times x minus the x coordinate, which is 4. And so this is point slope form. To get slope intercept form, we're going to distribute the -3. We'll have y minus 13 is equal to -3x. -3 times -4 is plus 12. And we're going to add 13 to both sides. Cancel, and y is equal to -3x. 12 plus 13 is plus 25. There's our slope-intercept form. There's our point-slope form. And we're done with 67. All right, let's do 68 and 69 now. 68 says, what is the average rate of change in f of x, which is x cubed, on the interval from 3 to 7? On the interval from 3 to 7. So 3 is a, 7 is b. Our formula is f of b minus f of a over b minus a. So this is going to be f of 7 minus f of 3 over 7 minus 3. So plug 7 in, that's 7 to the third power, minus plug in 3, 3 to the third power, over 7 minus 3 is 4. 7 to the third power, that's 343, minus 3 to the third power, that's 27, over 4. And 343 minus 27, that is 316 divided by 4, which is 79. And that is the average rate of change of this function on the interval from 3 to 7. And now we'll do question number 69. It says, what is the average rate of change in f of x equals e to the x power on the interval from 2 to 5, where 2 is a and 5 is b. So we have f of b minus f of a over b minus a. So that's going to be f of 5 minus f of 2 over 5 minus 2. Plug a 5 in, we get e to the 5th power minus, plug a 2 in, e to the 2nd power over 5 minus 2 is 3 equals. Now, this is technically an answer. We technically could leave the answer as e to the 5th minus e squared over 3. We could even factor out an e squared and make it e squared times e cubed minus 1 over 3. That's fine too. But I'm going to go ahead and do it in the calculator. We're going to do e to the 5th minus e squared. I'm going to hit enter. And then I'm going to divide by 3, and I get 47.008. And that is the answer to question number 69. That is the end of the review. And if you have any questions, let me know. Good luck on the exam.